Section 22.7 Hydrides and Dihydrogen complexes. When this transition metal forms a single bond with a hydridyl ligand, it's just a sigma bond. It's a very simple sigma bond. You may view this hydrogen as the negatively charged hydridyl ligand, and in this case, M is +1 charged. The oxidation number is 1. When you have a, let's say, MH6 complex, the oxidation number of the transition metal is +6 because you have a -1 charge on each of the hydridyl ligand. Now let's look at the reaction between the dihydrogen molecule and a transition metal. They form this MH2 transition metal complex. In this reaction, this M forms bonds with the two hydrogen atoms via two different mechanisms. The first mechanism, H2, may donate 2 sigma bonding electrons to the metal. The second mechanism, the transition metal, may donate d electrons to the empty sigma star antibonding orbital of H2. So this is also called pi backbonding. It's hyperconjugation. Now let's look at this. H2 has a bonding orbital with 2 electrons, and this bonding orbital may overlap with an empty d orbital centered on the metal. All right, so let's say this is positive phase, this is positive phase, and this is constructive interference, and that's why the 2 sigma electrons may flow into this empty d orbital of the metal. At the same time, if there are d electrons in this transition metal, these electrons may flow into the sigma star antibonding orbital of H2. So this is a sigma star antibonding orbital. Let's say this is negative phase, positive phase, negative phase, positive phase. Therefore, this is constructive interference between a negative phase and negative phase, between a positive phase and a positive phase. So this constructive interference tells us the 3d electrons can flow into the antibonding orbital of this dihydrogen molecule. And this is the so-called pi backbonding. Although this is not really a p orbital, it's not really an empty p orbital, it's an empty sigma star orbital, but it has the same symmetry as an empty p orbital. The hydrogen-hydrogen bond in this complex is weakened because of the loss of the bonding electrons. So the bonding electrons can flow into the empty d orbital of the metal. And also because of the gain of the antibonding electrons. So when we have electrons placed into the antibonding sigma star orbital, that will also weaken the hydrogen-hydrogen bond. And this is why many 4D and 5D transition metal atoms or atomic clusters such as palladium or platinum, they can break hydrogen-hydrogen bonds easily because of these two mechanisms.